MD.ai is a full-featured data labeling platform for medical imaging running on Google Cloud. You can easily bring in your datasets through the Google Cloud Healthcare API. Here, we will run through a quick demo showcasing this integration. First, we will create a Google Cloud Healthcare dataset. We have a simple Python script that creates the dataset and a DICOM store, then imports files from a GCP storage bucket into that DICOM store. We will load our Google Access token as an environment variable and run the Python script. Great. We've now successfully created a DICOM store with some sample data. Let's navigate to google.md.ai in our web browser. This is a dedicated HIPAA-compliant environment for us to create our projects in. During login, note that MD.ai will request the user for specific access to the user's Cloud Healthcare API data and cloud storage buckets. So let's create a new project and a data set that we will connect to our DICOM store. Note that we specifically indicate the source as Google Cloud Healthcare API. To create the data connection, we simply specify the endpoint information, including the GCP project ID, GCP region, the Cloud Healthcare API dataset ID, and the DICOM store ID. So once connected, the data will be read and processed in the background, and some metadata will be stored by MD.ai. But it's important to keep in mind the actual original data stays in Google Cloud. We can now launch the app for labeling. These are single view chest x-rays, so each exam will contain only one series with one image. The images are being loaded directly from the Google Cloud Healthcare API. This is a fully collaborative real-time environment where you can add additional teammates to help, adjudicate, or simply observe. Assigning tasks to users in your project greatly help facilitate the annotation workflow. So let's create a label for lung. For simplicity, let's make this a simple bounding box type, even though in practice you may want this to be a polygon or freeform shape. Let's make another label for pneumothorax of freeform shape type. Now we will draw bounding boxes over the lung fields. Using keyboard shortcuts will greatly speed up the process. Great. So the progress panel shows that we applied labels to all 5 exams. Progress tracking is essential in huge projects with a large number of annotators. So opening up the export panel, we can then export the annotations as a JSON file, which can be downloaded. Here we can see that it shows up in this Google Cloud Storage bucket. To use the JSON data, one may refer to our documentation outlining the data schema, or use our Python client library with built-in helper functions. So let's now visualize and double-check the annotations we just drew in a Jupyter notebook. In each project, we have an area where we can associate any number of Jupyter notebooks and run them directly in Google Colab. In Colab, you can enable cloud GPU runtimes for training machine learning models. These notebooks can be private to you or made public to all project users. So we have here a Jupyter notebook with code to load the exported JSON data containing our annotations using our MD.ai Python client library. We bring in the project images and display the annotations we previously drew as masks over the images. Looks good. All the lung fields are visualized. So another useful feature is the ability to import external annotations. For example, from the output of a machine learning model you trained. This can be immensely useful for semi-automating the labeling process or for model validation. Let's imagine we trained a model for predicting pneumothoraces, areas where the lungs have collapsed, and now we want to bring in the output predictions as segmentation masks. So we have here another Jupyter notebook running in Google Colab for doing just this. We will once again use the MD.ai Python client library. We just have to specify some IDs for the project, dataset, model, and label all these segmentation masks will be associated with. Going back to the app, we can see that all these red shapes outlined in a dashed line have magically appeared. As a reviewer or adjudicator, I could then go through and vote up or down on all these annotations. This has been a quick overview of a simple project making use of Google's Cloud Healthcare API. We hope we have shown just how easy it is to get started and to iterate on creating labeled datasets, an essential prerequisite for building useful and clinically relevant machine learning models.